So now then we start another section for DC motor. Now we go to something really moving, rotating, right? Instead of static machine not moving at all, right? So DC motor always become important. Why we do that? Because DC motor is simple. We can just purely to use DC voltage to drive motor. So like using battery or many kind of DC source, we can drive them. So application is so many, like robot, toys, even though some AC system, aircon system, ventilation system, anything moving, we tend to use a lot of DC motor. Because DC motor has been there for such a long time, so the market share is really huge. I think go up to at least 40% of the total market share. So that's why it's an important devices. We need to understand further about what it is. So firstly, to ask it, what's the difference between AC motor and DC motor? I think we heard about that, right? It's our first question. Simple enough question to ask you. Right? I think I asked you some time ago. This gentleman, DC and AC, what are they?
Well, it's the power, the one DC power. I don't know how the frequency changes.
I get some more. How about this already? Tell me. How AC?
What AC is changing?
Answer something?
I'm thinking that because in a DC motor you have to have some sort of controller to change the phase for each coil winding. I'm guessing you don't really need to do that with a DC motor since a three-phase AC motor would already have those 3 different phases built in, so you can just connect the wires and it'll create a current whenever one of the phases are at the crest of the sine wave.
Really good. I think you all help me to distinguish a lot of the difference between AC motor and DC motor. We all say is correct. For instance, DC can operate from the DC source, like battery, right? AC operate as from AC source. And also AC source, as Christian mentioned about more complicated, we look into single phase and 3-phase sine wave, how to balance them out, how to make them operate. So there's a whole thing in there. So in the first lecture here, we just showed you about the DC motor. Simple enough to start some things commonly known. So a DC motor, do you think a DC motor require a magnet, permanent magnet? I think in the toy you use at home, toy car, there's a little DC motor there. You find that there will be a magnet, right? So do you think all the DC motor require a magnet? What do you think?
Yes.
Yeah. Yes or no? And the magnet can be generated from other sources. But many DC motors do require magnet. But of course, many of them don't have to, because you can use other methods to generate a magnetic field. And then we also market size. I mentioned really large market size because the simple used to operate about the first motor appear in the world. So that's why fair enough. Then must have a large market. Then also operate by purely DC, easy to control. So that's why large market size. And does a DC motor require commutator and brushes to operate? So you see there's some contact point on the connection to the motor wire. So this is called the commutator and the brush. So what do you think?
Yeah.
Yes, many of them do require to do that, but not all of them. We do have some new motor, we don't need to do that. But all the conventional DC motor, we do require commutator brushes to build up the connection from the power source into the motor winding. And then the key component, major component DC motor, obviously will be some motor wire, permanent magnet, possibly commutator, and the brushes. There may be other components to examine in more detail. And then fundamental principle, why a motor can rotate? What's the basic principle? Anybody can name some formulation or name or scientist why a DC motor can move?
Magnetic magic.
Yeah, they're all
It's
magnetic.
the polarity of the input and output when it enters the magnet between it. And it creates a negative and positive, so it keeps the motor turning. That's what I'm thinking. Yes.
Or maybe about this. So in this section, we're going to show you about some basic principle how DC motor can able to move. There's some famous scientists in the history of money then show us how they develop the different type of the motor. So they are all quite interesting. Let's see what it is then. So we'll cover a number of sections like our fundamental knowledge for electromagnetic, and then we talk about the basic component and the motor equation. In this section, you can see many motor equations, quite a number of them. Maybe some of you have learned them, but if you haven't learned them before, there will be a number of equations. This equation need to be memorized because only a few equations. Basically, you can see I have here maybe more than 10 equations, but they're all important equations. As an electrical engineer, you have to memorize somehow some equation. So sorry about that. Although in theory, I should provide you with some kind of formulation book or formulation sheet or cheat sheet in exam. But as a good engineer, you need to memorize some good equation. Anyway, we also report about the characteristics for motor, how the torque being controlled. We also looking into the field circuit. Just now we mentioned about we can use PM permanent magnet to create a magnetic field, but we can also using coil to create a magnetic field. So this coil we have special circuit to control the field condition. So and then we make a conclusion. So let's see the fundamental. The first thing we try to show you what we call the Lorentz force law. I think you learned in high school, right? Lorentz. So, and anybody can tell me again, what have you learned in the physics? Lorentz force. We got many laws. Lorentz, something like this. But anyways,
Yeah.
I only need you to understand all these Fleming's law in the first lecture. I won't ask you any question exam, right? We just give you some basic fundamentals to start off to understand why we have the force generating the wire. So according to here, the Lorentz force is some kind of name to factor you about. We got a scientist called Lorentz. He created a law called this. So that could say, when you have a current I magnetic field, then you put the angle your phasor with general force relate to this formulation. You also relate to the length of the wire, length of the cable here. So that's a formulation. So that means the current and the B field, they have angle theta between them. As long as not equal to 0, you can generate force. So this is the plane. So if that is a plane in here, then generate force in such a way, right? That's basically what you're trying to mean. So if you know the vector, then it calls for that I cos B will give my force. I myself remember in such a way, easier to remember. But of course, you can use the Fleming law to examine which one is which, right? That we learned in the high school. So basically, this is what you say here. But for electrical machine, although the formulation called sine theta here, but we usually try to make the angle theta become 90 degrees. For motor power where we try to make the wire and the magnetic field become 90 degrees, we can able to get more force. We seldom make it in angle. We don't need to do that for design motor. Make that 90 degrees, you got maximum force. That's what we're trying to do. So basically, that's the first equation you need to understand, or first phenomenon from this scientist to learn about how the force come out. Whenever there's current pass through, the B field, then we generate force to move the wire. That force will create you the basic principle of motor. And then you may ask me why a current force you generate, a magnetic field will generate a moving. Why is that? Although the Lorentz say that, but you can rethink why we have force there. So what do you think? So when I was a little kid, and then I asked myself, why the force? Because whenever the current pass your mind, you generate its own magnetic field. Why you can magnetic? And then this magnetic field, for near magnetic field and why generate its own magnetic field, they are opposite each other, both are not pole, and therefore push this wire away. So that creates the force. So mainly the Lorentz force are mainly electromagnetic repulsion. This wire pass through current, get magnetic field. This material will be interact with this one. So that cause the wire to move very some if that counts the internal, not internal, the basic principle why we create for. So we formulate this into F equal to IBL sine theta. That's how we come up to it. So when this guy derive this thing, you just find the relationship with this ratio, and then later on when the mathematician they change them into cross product I cos B equal to force. So that's why I can see all the geometric are really complicated. They got the cross product, dot product, and the conscious, not the geometric law, so complicated. But for engineer, we try to use a basic principle, simple way to explain the phenomenon to you, how to design properly, rather than just give you complication of the formulation. I will try to show you a simple way to do that. So that is the Lorentz force. And then other people, when you have high school, then you learn the Fleming left-hand rule. That's how we control about how to give you the emissions. So that's how we learn the first emission. You learn a few years ago, right? So current, this when the current flows this way, the field this way, that's the force. So now in here, then current this way, and then the field when this way, the force is this way, right? We all learn that in high school. How I remember, I'm not quite sure how I remember this, will be this mean the 5 finger, the center finger, or C center finger. C, the field, the first finger is the field, the more powerful one, the front powerful is the force, right? So how I remember. But when you're in this field for many years, I mean, so you should be able to do that. So you think your own way to remember the force direction, that's quite important, right? All the tests are that can be. So that gives you the basic physical phenomenon of the law, how we change the force. Basic principle behind mainly about the repulsion for two magnetic field angles. So that's how we develop the first few slide about how we create the force for the DC motor. And then to do the S, I mentioned the Lorentz law relate to sine theta. So we usually for design, we make the sine theta become maximum, then the sine theta become 90 degrees. So that is to say, if you got parallel magnet for DC motor, you got two parallel magnet here. When the wire pass through it here, we tend to make the wire become 90 degrees to the magnetic flux. So that's you can see here, that's 90 degrees. So that's why you got maximum magnetic flux. That's all the basic design of the electrical machine to do that. So this picture will show you there is 90 degrees, so that we're able to create maximum force. We never put the wire in such a way because it doesn't do anything. It's 0 degrees in parallel, doesn't create any force. So that's why I can see that all the machine, when they design them, when the wire pass through between the 2 p.m. or the field polarity, then they will make the wire become perpendicular to the magnetic flux. So that's the basic design. No matter how you do that, you try to make it in such a way. So that's how we build up the basic configuration for electrical machine anyway. Any question up to this point? Now, do you have any more fundamental principle why we now can make up a motor, construct a motor? That's the basic theory behind how we can construct a DC motor anyway. So next section is the key component. I think in high school you do know about the basic component. Like in here, we got the stator. Stator means it's not moving, stationary. And then that can be used to provide you with the container to contain the rotor part. So that usually can also have the permanent magnet there or the field winding there. And the rotor will be in the center, usually have the so-called armature. You have all the armature wire in here, in the middle, so moving part. Because the wire inside, we need to conduct the electrical current to the internal. So to do that, we need the commutator and brushes to connect them. So here is configuration for the commutator and the brushes. We also have shaft to provide us with the output shaft for the rotation. That's really basic configuration for this motor. So if you go home, you see any toy, you can open up, you can also see this kind of the configuration. So this is another famous graph you can see in many textbooks.